Hello everyone, this is Qingyu Wu. I'm an assistant professor at Penn State University. Although I cannot be there with you in person, I'm very excited to virtually share my work on AutoGen with all of you. This is the agenda for today. I will start with AutoGen key concepts and benefits in the broader context of AI agents. Next, I will share examples and use cases of AutoGen in action, and also an outlook of the project. First, what is AutoGen? AutoGen, in a nutshell, is an open-source programming framework for agentic AI. A core concept of AutoGen is multi-agent conversation, which I will introduce in a few minutes. This project was initialized early last year and officially released last September. Upon its initial release, the project has exploded in usage and got recognized in both industry and academia with multiple awards and tons of use cases. For the first question, one obvious thing is that people will be leveraging all kinds of AI models in the future applications. But the inference cost to just models is probably not sufficient. Although we are having more and more capable models, those models may still have all kinds of mistakes due to their intrinsic limitations. For example, hallucination, and not being able to leverage the latest information or knowledge or private information beyond the training data. We may want to leverage all kinds of tools, external knowledges, and different types of models in a real-world complex application. This February, the Bear Lab in UC Berkeley published this blog post, The Shift from Models to Compound AI Systems. This blog post rightfully pointed out that there is a shift from models to compound AI systems that tackle AI tasks by combining multiple interacting components. Another trend is the rise of AI agents. The agent concept is not new. It has been there for decades. But now we are in a truly daunting age of agents, because an agent now can interact with the world autonomously and intelligently thanks to the capabilities from AI models. The interactive nature plus the autonomousity of an agent make it an ideal building block for AI applications. Now we have an idea about what future AI applications look like. First, they are software systems with multiple interacting components. And second, AI agents are likely the first-class citizen in that system. The next question then is, how do we empower every developer to build them? Of course, one can always build it from scratch. But once you start trying this, you will soon find yourself constantly dealing with all kinds of tedious low-level issues. In this context, we propose this multi-agent AutoGen framework. AutoGen essentially hops on two important concepts, the agentic abstraction and second, the multi-agent orchestration. The agentic abstraction makes it possible to wrap various of components or entities, including AI models, tools, knowledge base, or even humans, into an agent, and more specifically, conversable agent in this framework. With this unified conversable agent concept, you are supposed to be able to use AutoGen to simplify any complex workflows involving large language models and unify them as multi-agent conversation. Here, this leads to the second key concept, multi-agent orchestration, which handles how agents shall be combined or used together to jointly solve a task. With these two components, building an AI application with AutoGen can be streamlined into the following two intuitive steps. The first step is to define agents you may need. AutoGen provides customizable and conversible agents, meaning that an agent can be easily configured to have specialized capabilities that can chat with each other to solve a task. You can understand it starting from the language agent mentioned before. A vanilla language agent can use large language model as the brain to take actions and interact with the world. AutoGen takes it one step further. It allows you to customize the components within an agent that determines its capabilities. For example, it can be a model, a database that you can query, a tool, human inputs, or any combination of them. In fact, the so-called environment can just be an AutoGen agent as well. The other important aspect is the unified conversation interface, which means that you don't necessarily need to distinguish the so-called actions and observations. They are all just inter-agent chat messages. Once you have the agents there, the second step is to get the agents to talk. We call it conversation programming. This can be as naive as multi-round two-agent chat in its simplest form, as shown on the right-hand side. Either an environment agent or an agent with an AI component, depending on your need. So beyond this simple two-agent chat, you can basically craft any pattern you like to use. Some frequently used ones include sequential chat, nested chat, group chat, and hierarchical chat, which I will give examples for in the next few slides. Now let me quickly go through the concrete examples. This example is a blog post writing task involving a simple two-agent chat, one acting as a writer and the other one acting as a critic. The writer is responsible for doing the writing, basically using a large language model to generate a blog post, and the other critic agent will also use large language model to provide feedback on the generated content. So this is how you can realize this simple two-agent chat in AutoGen. Basically, these two agents can do multiple rounds of chat back and forth fully autonomously once a chat is initialized in this way, until a stopping condition is satisfied. Another example is the customer onboarding task. This is an example task which has clear separation of subtasks or SOPs. For example, one subtask could be about collecting customer information, and one subtask to survey customers' interest, and one subtask to do customer engagement. The later task may depend on context from previous tasks. In this case, you can use AutoGen to craft a sequential chat to accomplish this, as shown in the in this figure on the right-hand side. With sequential chat, you can construct 3 corresponding sessions of chat agents to do each of these subtasks, as shown in this list. So each element of this list is a session, is a chat session. And you can use a summary from a previous chat in the later chat, as visualized on the right-hand side of this slide. So another conversation pattern was mentioning is nested chat. So nested chat intuitively can be understood as an agent having an inner monologue. This agent only share what is necessary with the external world or external agents. This allows an agent to do more sophisticated reflection without distracting the other agents. For example, in this blog post writing task mentioned before, you can use this nested chat to realize a much more sophisticated reflection with multiple experts. For example, here we are including experts, including SEO reviewer, legal reviewer, ethics reviewer, and each of them check a particular aspect of the writing, and we include another meta reviewer. This meta reviewer will aggregate all the reviews from the other experts and only return a summary or a takeaway from this nested chat. And here is how you can realize this nested chat in AutoGen. So basically, you just register this nested chat. It's kind of like a tool, but allows you to do agent chat in this session. And basically, by using nested chat, you can have a clear separation of some of the context, so that you can keep the conversation between the writer agent and the critic agent clean. The most commonly used conversation pattern among the users of AutoGen is probably group chat. In group chat, a group chat manager here is responsible for selecting one of the agent, for example Bob, to do a certain task based on the context and the role of each of the agent. And the group chat manager could be driven by a large language model, for example, meaning that you can use a large language model to try to understand the context and try to understand the roles of each agent and to do a speaker selection. Or you can specify a transition rules, for example, which agent to use after a particular agent. So this is all feasible within the AutoGen framework. So in our original paper, we studied a number of applications in depth. These applications cover use cases with different levels of complexities and involving different patterns. You are encouraged to read the paper and the related notebooks for more details. In addition to the conversation patterns supported, I also want to highlight several important things we can do, several more important things you can do with AutoGen. One topic among them is around advanced prompting and reasoning. There are numerous prompting techniques that have shown to be useful in enhancing the reasoning capability of large language models. For example, chain of thought, react, reflection, and etc. Here, let me quickly demonstrate how to realize react in AutoGen. So basically, you start with a large language model agent with a react prompt, which instructs the model to think first and then take certain actions before coming up with the final answer. And on the other end, you should create an agent with a tool executor. In this specific example, I want to use a search engine as a tool because I may want to use this search engine to search for some latest information that is not available in an AI model. So when asked the question, what is the result of Super Bowl 2024? The large language model agent now give it a thought and actions to take. Here you can see that it is saying, I don't have the information readily available. I will use the search tool to look it up. And it then gives the arguments to the tool Super Bowl 2024 result. So this is pretty nice because the large language model actually is not trained on the latest data, so it does not have the information about the result of 2024. So in this case, using this tool is pretty helpful. And here, once the other agent receives this instruction, it then executes this query in this tool and gives back the search result as the message. And here you can see that this is a raw search result from this search tool. And then the assistant agent will synthesize the information and give the final answer. Here it is saying that according to the search result, who wins this Super Bowl 2024, and give the final answer. So this is basically how you can react into a two-agent chat in AutoGen. So this is pretty neat. This is just one example of advanced prompting. Following a similar philosophy, you can actually create or realize almost all advanced prompting techniques with AutoGen. For example, reflection, LAT, which is short for language agent tree search. And here, through these two links, you can find example implementation of this to advanced prompting. Another topic probably of interest is RAG, which is retrieval augmented generation. Different from a naive RAG, AutoGen use an agentic RAG approach, meaning that the RAG component is added almost like a tool on top of an agent. One advantage is that you can realize RAG without significantly changing your application architecture. And another advantage is that this allows you to do multi-round retrieval depending on the context. As shown in this example, on the left-hand side, we are using a naive RAG, which is basically doing one-time retrieval. And through this one-time retrieval, you can find that we actually cannot find the relevant information at the first place. But if you use multi-turn interactive retrieval, you will be able to leverage more context in the query, so that it's more likely you can actually and eventually find the answer to the query, to the question. So that's a big advantage of agentic RAG or multi-round interactive RAG. There are actually a lot more about AutoGen can provide, including building memory management, multimodality, and a lot of community integrations. Due to time constraints, I will not cover them one by one today. If you are interested in learning more, definitely check the repository on GitHub. Besides that, we also have a deeplearning.ai course with Andrew Ng, which covers many interesting topics as well. Next, I will cover some examples of AutoGen used in action. Let's start from use cases in the science and engineering domain. AutoGen is used in these domains to enable emergent cognition and real-time knowledge synthesis, as detailed by this professor from MIT in his blog post. The first example use case is about a mechanics problem. So in this mechanics problem, multiple agents are created as shown on the left-hand side of this slide to collaboratively solve a complex mechanics task using the group chat conversation pattern introduced earlier. The group chat manager here is responsible for coordinating all the individual agents. The agents and the conversable patterns are defined by the domain experts. One thing worth mentioning is that the executor agent among these agents here is able to leverage physics engine to solve mechanics problems. So this is make it possible to solve this problem more reliably, leveraging all the advanced tools in physics. And a similar example is for protein design and discovery, where the agents leverage both domain-specific knowledge and domain-specific tools, such as physics simulator, to solve the specific problem with better reliability. Next, I will give two example use cases of AutoGen used in production.
Hi, I'm Justin, co-founder and head of technology at Better Future Labs. Our startup studio founds and invests in new technology companies. As you could probably imagine, we do a lot of research, screening, and analysis to support our work. It could take up to a week to evaluate each business idea, and we'll review hundreds of new ideas each year. We are using AutoGen to replicate the work of human research teams to help analyze these early venture ideas. Investors usually employ teams of analysts to research and validate investment opportunities. The process of analyzing things like a company's addressable market size, their competitive environment, and more abstract concepts like the feasibility of building technology is a slow, somewhat repetitive, and an expensive process. So instead of hiring a new team, we built one. We modeled our teams of agents after real consulting teams. So there are managing directors leading each research area, research managers creating tasks and reviewing work, and analysts actually conducting the research. Here's a look at our competitive landscape team analyzing an idea called Thunderdome. The managing director starts by creating the research objectives for the team.
Team heads up. We need to dig into the product Thunderdome within the AI hiring space. Here's what we're after. Competitor intel. What are they offering and how does it stack up? Pricing. How much are they charging and what's their model? Market insights. How big is the market and what's its value estimated to be?
In response, our eager analyst immediately begins to work on the request and comes back with initial research.
Hey, here are the competitors I found. TestGorilla offers an AI test to evaluate candidates' understanding of core AI concepts and their ability to solve AI tasks. Skillspace AI, it's a platform for evaluating developers. It includes challenges and project-based evaluations. I also found Glider AI.
But our manager has something to say about this. It critiques the work and provides guidance on how to improve the research. By the way, sounds like the manager may be having a bad day.
Researcher, this is missing the mark in your competitor analysis. I'm not seeing any specific details of how their offerings stand against Thunderdome. Use platforms like Bloomberg, Statista, IBIS World for reports which can help. I also need the specific funding amount details for Thunderdome and its main competitors. If Crunchbase and PitchBook access is limited, you need to get creative. Look at SEC filings or use databases like Prico. Lastly, your evaluation of competitor aggressiveness is non-existent. Look for market share data, examine their market strategies, and articulate what this could mean for Thunderdome. From the next report, I expect less of what you can't do and more focus on what you've actually done. Try again, but don't try do.
We made the agents very blunt, which is fun, but also preserves the amount of tokens they are consuming. Luckily, our analyst takes the feedback in stride and starts to improve the research.
Confirmed. Going to dive deeper into Thunderdome's competitors.
The end result is the agents produce a contextual analysis in each research area in our investment playbook, like what we are seeing here with the competitive landscape summary. They then score each idea based off of every pillar in our investment playbook so that we could compare and contrast different ideas with each other using a quantitative method. They then justify each score, providing statistics and facts to back up the score they gave. All of this is done in an average of 7 minutes. AutoGen has changed the way we look at investments and has made a huge impact on our business. Thank you to the AutoGen team for their contributions and hard work in driving the initiative forward.
Our web automation multi-agent solution called AgentE leverages the AutoGen framework to simplify and save significant human time on multiple tasks that could span across applications. In this example, I've received an email from the doctor's office requesting that I fill out a form before my next appointment. So in this case, I'm going to highlight the text that I need help with. And once I go here, it's automatically going to copy the text because it knows this is what I'm referring to. And I'm going to ask it to complete the task that is referenced in here, but wait, not submit this until I take a look at it. So in this case, it's going to navigate to the form. It's going to fetch the different elements. For example, the form input fields. It can also find out the user preferences, and based on that, it's going to start and fill out every single part of the form based on the user's information, user's preferences that it has. And once it's completed, it's going to stop, just like I asked it to. And I could choose to submit the form if I wish, or I could just let it be.
So beyond this several use cases, there are even more from the open source community. The project also benefits a lot of contribution from many of them. So huge shout out to all of them. Next, I'd like to share the project outlook. So first, as a short summary, Multi-agent conversation is desirable design pattern as it allows improvement over natural iteration, facilitates divide and conquer, and allows flexible grounding and validation. AutoGen as a multi-agent conversation framework provides good modularity, allows natural human participation, and helps with fast experimentation. AutoGen already has a lot of support and have been widely adopted. There are a lot of developers from multiple organizations and helping developing AutoGen. And at the same time, there are also researchers and graduate students working to push the frontier. We are now working on multiple fronts regarding aspects such as evaluation, interface, learning/teaching/optimization, and integration. For integration, we now support over 75 models and support almost all major vector databases to be used in AutoGen's RAG component. AutoGen even allows you to use agents from different providers as well. For example, you are able to create an AutoGen group chat with AutoGen agents, with GPT assistant agent, or even with Llama with Lantern agent or Llama index agent. For learning, teaching/optimization, I would like to quickly share 2 ongoing work. The first line of work I would like to introduce is AgentOptimizer, which is framed an agentic way to train large language model agents so that it can behave better and better with more and more experiences. There are actually many dimensions of multi-agent system where you can optimize. For example, which model to use, the prompt to use, and the tools to use, how many agents to include, the organization among the agents, etc. AgentOptimizer basically gives you a framework to improve all those aspects. In this specific paper, we are using large language model as the optimizer and iteratively optimize what tools to use according to the historical conversation and performance. Basically, we will have an agent training phase and the agent testing phase. In the training phase, the agent will create new tools or reusing existing tools or removing certain tools from the pool, depending on the utility from those tools according to the historical observations. We call this progressive function update. In the testing phase, we could just leverage those learned tools or functions to solve the task at hand using those tools. Another work I want to highlight is AutoBuild. When creating a multi-agent workflow to solve a task, you may have the question about what agent to use and how they work together to solve the task. AutoBuild is basically a work that helps answer this question. It is a method that could automatically create a multi-agent system using AutoGen, then finish the task with the multi-agent system. Let's look into the process a little bit more. Once a task is received, the method will initiate a process with 2 steps. The first step is the building step, which creates all the agents you may need. For example, in this task where I want to write a blog post about the stock price of NVIDIA. This AutoBuilder is creating agents such as stock market analyst, financial journalist, data research assistant, and SEO content optimizer, which in my view makes perfect sense. The agents are all also specified with the proper models and the proper prompts. The next step is an execution step, where the agents are put together to actually solve the task autonomously. So from the user's perspective, with this AutoBuild method, you don't need to worry about the agent building process and instead have an end-to-end solution from a task to a final answer. Of course, all these progresses being introduced, AutoGen is still under active development and research, and evolving at a very fast pace. There are many hard open questions. The entire AutoGen community has been working hard on these problems from a few perspectives, including how to design optimal multi-agent topology, how to create highly capable agents, and how to enable scalable safety and human agency. You are absolutely welcome to join our community to make progresses together with the best engineers and best researchers. Finally, I want to give a big shout out to our incredible open source contributors and the huge support from more than 19,000 members in our Discord community. Come and join us in shaping the future of AI. And finally, I'd love to answer any questions you may have and have more discussions with you as well. Since I'm not in person, you can find me in Discord, and I look forward to hearing from you.